Hey, welcome to Algebra Part 3, and it's called More Maths Families. Have we had any maths families yet? Hey, well, I think we did back in Part 2, Families that Look at Algebra, and we'll review that in a little bit. But I've got a question for you. Here it is here. Around the screen I've got 4 little entries there, and my question for you is, how can these be families? Well, let's have a look. How could this one be a family? Something to do with a connection between X and Y maybe. We might get onto that later on. And here's a different family because there's the same X's, but the members are different over here. What about these? How could they be families? Well, it looks like got some sort of grid here. The scale, it's not labelled though. The scale up here. And a line. Maybe the family here is a set of points that form that particular line. Here's a different line. So can you see a lot of stuff in maths can be related to families, connections, generations. How do you create any more points on this line down there or up there? What generation will give you more points? That sort of stuff. Hey, so let's get into this, and I've got a fun activity for you coming up. So come down and let's have a look. First of all, what maths families have we already seen? Back in Part 2, we were looking at family approach to algebra, having a look at algebra from a family approach. What did we do? We drew up some rectangles, didn't we? And the rectangle family were P28s from an A4 sheet of paper. We wanted to create rectangles that all had a perimeter of 28 centimetres. Okay, we might have called that the surname. And what would be the generation? What generated our different shapes? Because there was that one, and then there might have been, this long skinny one like this, or like this, okay, and so on. So they're all members of a family perimeter 28. That's the surname. Well, how do we generate them? Well, we chose different lengths, didn't we? Along here. Chose different lengths, and of course that means the breadth changed according to the perimeter of 28. I'm not going to go into too much math there yet. But what would be the family, we've done the surname. Well, what would be the first name of each of these members? Well, you could have given it the area. They've all got different areas, haven't they? The areas of each of these. So what would this one's name be? Could be surname P28, perimeter 28, generation, length, so generation would be the length, and the first name would be whatever the area was there, and that would distinguish that particular member of that family from this one and from this one, because they would have different areas. Maybe you could think of it like that. And what about the other family we looked at? And that was the boxes, the A4 boxes. I've got a little box here, mate. Okay, draw this little box up. And of course there's a whole lot of possible boxes coming out of a A4 sheet. We might call the surname A4 box because we cut corners out, if you remember. Let's just go back, A4 sheet, and we cut squares out of the corners. Okay, so surname could be an A4 box. There are different sorts of boxes possible here. Bigger squares cut out, and going to get a different box there. So what could be the generation name for this? Could be the side of the square, the length of that square that we cut out over here, come down over here. And that could be the generation number. And as we do different size squares, we generate different boxes. And then what would be maybe the first name of each box? Well, what do they have in common? What do they have different? Well, what could you fit in here? What is the capacity or volume of this box? Maybe that could be the first name. Thinking families have things that are the same and things that are different. Okay, so we're looking at those sorts of ideas as we go more into math land. So we've done a little bit of math families with area and volume, I guess, with geometric approach to families. But do you remember early on, way back in this course at the beginning, on your beginning of your maths career, you had some families, didn't you? Don't forget this, dude. This is Pythagoras. Do you remember this from a number presentation? If you don't, you can go back and have a look at that again. Pythagoras, who was a bit of a philosopher as well as a mathematician. And he said the world is number. A lot of the things he found and patterns he found in the world, he could describe with numbers. Okay, and around the screen you can see lots of families of numbers. You've got the integers, positive integers here, and we've done all this. That's a family. We've got negative integers here. Okay, and it was natural numbers. What are natural numbers? Starting at 1, the positive integers from 1, I think. And then you've got fractions or rational numbers, square roots, powers. So we have got quite a few families lurking around in mathland. So keep thinking about that. What have they got that is the same? What is different about all these members of these families? So let's go on with this exciting activity I got for you. So come down here. And what's this? Well, your teacher will hand you out a sheet with this on it so that you can fill it in. A bit hard to fill in on the screen when it's a video, mate. Or you could copy it out into your book. And what we want you to do is to run a program on the Casio 9860 Plus where you're asked to guess a number. So this goes back to algebra. What's that? Think of a number, double it and all that. So the calculator is going to run, you're going to run this program on the calculator and you're going to generate different numbers. And you have to guess what the calculator is generating. What think, the program is short for think, I think. Think, too confusing. Anyway, the number Tink was thinking of. Okay, so Tink is the program's going to think of a number, which is going to be a mystery number. It's going to multiply by something, which it will tell you. It's going to add or take something away. And then it's going to give you the answer. So can you work out what the number was? It's similar to that algebra, what's that presentation. So what I'm going to ask you to do now is to go to program on your Casio 9860 Plus and run the program 7 times. Why 7 times? Well, there's 7 boxes here, mate, and I want you to fill in the result on the first run with what the program tells you. It's multiplying by something. It will tell you later on what it was thinking of. You have to try and guess that from the program. And it'll tell you all these pieces of information at the top. Now, I want you to do it 7 times, fill it in, and then I want you to repeat it, a set of 7, repeat twice more. Okay, so you're going to have 3 of these little tables to look at with all numbers filled in the spaces. Do you get it? Now, you might say, well, Huddy, I don't have access to that program. And I'm going to say to you, well, you can share mine, mate. So once you've run that 7 times, filled in your table, and done it twice more, so it's a total of 21 times. But I want you to restart the program. Don't just do 21, one after the other. I want you to restart the program and do 3 lots of 7, because Tink resets and looks at it a different way each time. And we want to analyse what this little dude in this calculator is doing, mate. Tink's a funny little fellow. All right, so come down, let's look at, well, do that now, and pause the presentation. Sorry, we'll get rid of that. Pause the presentation, and I'm going to show you what I got when I did it. Okay. Okay, this is what I got. This is on one of the runs. I'm only going to show you one, and then we'll talk about it. What parts can you see are the same and define the family? I'll give you a little hint, mate. Look at the red. I think the red's a clue. So as you went through and ran the program for the first time, and you did 7 shots at it, had 7 shots, then what you found was Tink always multiplied by the same number and added or subtracted the same number in each go of the 7 before you reset it and had another shot. So you should get something like this. What do you reckon? They are the things that are the same. We get generating members of the family. So let's try and apply the idea that we've been building up. What is the same? What is different? For naming members of this mathematical family. So come down here now, and here's my next question. Look at the colour, mate. Use the idea of surname, first name, and generation to describe the members of the family. These are the members that we're producing, isn't it? Okay. Look at the colours. Colours are a clue. Okay. So, what do you reckon? Well, this one and these two are the same, aren't they? They're the things that are the same every time you ran the program. So that would be the surname there. And could you see that to distinguish each member of the family, you might use that number there. That's their first name. So what's a generation? How are these members generated from this family? Yes, as Tink thought of a different number and did this process of 2 times it take 3, a different member over here of a family was generated. So the green here suggests that this is the generation and this is the first name over here. Do you get the idea? Thinking about how a particular family of numbers could have come about or could have been a generation or generated by our process, our mathematical process. Now, I've got a little bit of a challenge for you. I want you to remember back to, what was it? Algebra. What's that? And what did I do there when we were thinking of a number and trying to solve a puzzle? What did we use? I want you to see if you can use a similar approach to describe this family now. How would you describe it in Mathland? Think about what Tink was doing with these common steps here. Okay, so what was Tink doing? Let's put it in words. Okay, it was doubling the number, double the number, and subtract 3. Okay. Now from algebra, what's that? That initial presentation, you should have a good idea of how we could describe that mathematically with a part of a mathematical sentence. Have a think, pause the presentation, and what would you come up with? Okay, here we are. Double the number. We could say, let the number be x. Double it is 2x, subtract 3. That could be a way of describing what Tink was doing for this particular run of 7 shots. Double the number and take 3. And that equaled a family member. Okay. How did we get the different family members? We used different generation numbers in there. I don't know, you might like to think, hey, we've still got words in this, mate. That doesn't look like a mathematical sentence to me when you've still got words in it. So maybe you might like to say, how would we get rid of the words there to describe what is happening in generating all these members of the family over here from different generation numbers? Okay, think about that. Maybe talk to your classmates, because the answer to that is coming up in the next presentation. I bet you can hardly wait, and you'll need to use your calculator. So bring that along, mate. Catch you then.